Good afternoon. Welcome to Farewell to a Trade-Off. Thank you for your attendance and thank you for your attention. My name is James Saul. I'm a solutions architect within the global financial services practice at AWS. I'm going to first of all set the scene and then add some context, and then I'm going to hand over to Kieran Broadfoot, who's the CTO of hosting at Barclays, and Jonathan Turner, who is the chief cloud architect at Barclays. So first, a little bit of context, because context is king, right? So if I said, let's go for a walk, that sounds like a pretty simple thing to go do. But if it was a spacewalk, I think that would be a fairly different proposition altogether, right? And so it is really with universal banks, global, systemically important financial institutions. They have tens of thousands of employees worldwide. They are strictly regulated by multiple regulators in all those different jurisdictions they operate in. Typically those sort of regulatory controls are interpreted into bank policy. Bank policy is then codified into processes and technical solutions, and then those systems, those solutions, those processes are driven down deep into and frozen into that infrastructure. And it's the benefit of the benefits of the cloud that people have talked about for some time as being things like cost reduction. And that's all very well and good. People have reaped those benefits for a long time. But what we hear year after year is that agility is the thing that trumps all of those things. So the question then becomes, how do we take agility, which is the ability to affect change quickly, to take great ideas and bring them into production, turn them into reality quickly, to bring new business propositions to market, become highly competitive. And how do we have that, and at the same time have governance and control? So that's what the journey that ultimately Barclays have been on, and that's the journey that Kieran and Jonathan are going to take you through. They're going to explain the processes and the thinking that have led to this moment, and also, therefore, how they've ultimately achieved this and built this. How have they set about the very ambitious and excellent task of trying to imbue every person in their organization with these cloud superpowers, grant them access to these agile capabilities, yet at the same time ensure that they've met their governance and control objectives. And so with that, I'd like to hand over to Kieran first, who will then hand over to JT. Thank you very much. There you go.
Hi, good afternoon, everyone. I'm Kieran Broadfoot, and thanks for coming to our session today. We're going to be spending the rest of the session talking about the journey towards public cloud for Barclays. This has been a reasonably long journey for us. We've been at this for about 2 years. We don't expect you to agree with everything in the slides. Some of it you may actually have a bit of a visceral reaction to. But we wanted to kind of spend some time talking about how we thought through the process of delivering public cloud, and indeed, how do we actually technically implement it? And with my colleague Jonathan Turner as the lead architect on this, we'll hopefully give you something to be thinking about. So, I don't know very much about boats. I certainly don't know how to drive one, and I know drive is not the right verb. But I do know about enterprises, and they're large oil tankers. And it's fair to say that an oil tanker, when set on a certain trajectory, takes a really long time to move. And so the question, when you think about these large enterprises, is what's the right way to think about delivering public cloud? And we thought about it, and there's kind of two key ways to think about this. On the one hand, you could enable very specific business applications, quick to deliver, very timely, solve some real business opportunities, but may not lead always to the right outcome, and we'll talk more about that on the next slide. The alternative is hard. It's much harder, which is to turn the oil tanker which is to say, how much of the world that we inhabit today in our enterprise is still fit for purpose when utilizing public cloud? And how much into the detail do you want to get to in order to think about that world differently? What do you change? What sort of attitudes need to change? What sort of control mechanisms need to change? Much harder, many more stakeholders. Could be argued leads to a better outcome, and we're going to try and convince you today that it does. So why not take the easy path? Well, firstly, we're gluttons for punishment at Barclays. We enjoy the fun of doing something difficult. But we're worried that if we tried to solve for specific business opportunities, we'd reach a kind of false summit. You start climbing up the mountain, you're trudging all the way up there, you kind of reach the first point, and you kind of go, great, we've switched on public cloud. But it may not solve all of the other use cases you're looking for. And so as a result, and one of the things we really want to say here is that there's this opportunity to kind of rethink most of what you do inside your enterprise. You're mortgaging that opportunity to change the future. You're taking now and giving up for the future, and we don't think that's necessarily a good outcome. And indeed, your expectations may not match reality. You'll get some of the way, but some of those control points, some of the mechanisms you use to manage your infrastructure cause friction in your environment, and that leads you to, again, not realize the full potential. So, obviously, the way I'm framing this, we chose to take the much harder path and switch on a foundational cloud platform. And our goal was to reach the point where we could enable a general purpose environment, effectively reach feature parity with our own data centers, and then layer on all of the additional capabilities that a cloud vendor such as Amazon would provide for us. So, know your true objective. What are you actually trying to achieve? I'm sure all of you would have used some of these words in your PowerPoints inside your own enterprise to convince others that switching on public cloud is the right thing to do. Obviously, you want to switch on, you want to enable DevOps, you want to enable CI/CD, you want the innovation, you want the optimization of moving faster than you do today. The problem with these words is they only tell part of the story. It doesn't necessarily explain how you're going to change the technology business model that you enable in your organization. It doesn't necessarily explain how you're going to refactor the way you operate, what kind of cultural changes are required in your organization. And whilst we're not true enterprise architects, there are certain methodologies that do help in understanding and thinking about what are you trying to achieve. For many of us, this is once in a career opportunity to change the way our organizations work. And so it's worth spending a bit of time thinking about the implications of that. So in practice, what does it mean for Barclays? It should be self-service. It should be API-driven. These are obvious factors. These are obvious thoughts that many of you will be having, but it's the layers down that get more interesting to us. How do you enable straight-through processing? We talk about that in financial services all the time, straight-through processing of our financial transactions. What's straight-through processing for technology? We use the words DevOps and CI/CD, and we use all the blah words that go with that. But what does it mean in terms of how you enable a change in behaviors of many of the individuals in your organization? The next point I really want to make clear, delivering public cloud for us, we sit in infrastructure. But we don't necessarily consider ourselves an infrastructure-led team. It requires engagement from many other parts of your organization. Infrastructure, app dev, tax, legal, data privacy, legal, so on and so forth. All the different groups you need to think about. And as a result, it requires us to think more holistically about enabling public cloud. And indeed, what it should do is allow you the opportunity to go and lower and remove process and technical debt from your organization. So what it means is that you end up with this very complex interplay. And to give you some examples of the kinds of technical debt we're referring to, I'm going to hand over to my colleague, JT.
Thanks, Karen. So large organizations like ourselves, large enterprises that have been around for 300 and some odd years, have a bit of technical debt and process debt. Many organizations do. And unfortunately, as part of this journey, one of the things that we realized we had to do was actually start to pay down some of that debt. So technical debt kind of examples we talk about here, we've got very bloated operating system images that we use in our company. That's because on our static on-premise world, they don't have those kind of evolutionary pressures to make them smaller, to make them their first boot time faster. But in AWS, that's now real money out the door. The larger that image, the longer it takes to get value out of it is actual money leaving the firm. So there's an element of technical debt there that we are now sort of motivated to pay down on. Then we have process debt. So process debt, we all have many processes and procedures in our firms. They're all designed under a context of that static on-premise world where we weren't thinking around some of those things like straight-through processing for delivering your infrastructure. We weren't thinking about CI/CD and DevOps. And also over many years, there have been events that have happened that we've added on to that process, made little changes here and there, which are almost like scar tissue on the process, making it more complicated over time. And so as part of moving to the public cloud, we've also had to look at that process debt and pay some of that down. So an example here is around our CMDB. Our processes are all based upon how do we track our operating system instances in our CMDB. Well, what does that mean as your operating system instances become highly disposable, very transient, maybe there for a matter of minutes? Are they really assets that we need to track? What does it mean for services which aren't operating system based for you as a consumer as AWS? Do you track S3 buckets in your CMDB? Do you track any one of the 150 some odd resources that you can get in AWS that's continuously growing? So how do you have your processes around this, something that is going to be cloud compatible as well? And then many other processes that we've had to look into, things like our incident response processes, things like our internal charging processes. All of that is kind of part of this journey and something that needs to be looked into. So unfortunately, there is a fairly large element of yak shaving that goes on around the edges of getting to that capability that your developers are hankering after. So a typical mindset in large enterprises around how to operate best practice for IT management can involve some of these things. So, for example, if you've got a control point, you'll tend to want to centralize it. Bring it back to a central point, make sure it's well controlled. You may want to have a small number of standards and things so that you can manage things at scale. And you want that one throat to choke. But how do these kinds of things and this kind of mindset work with what we're trying to achieve, as Kieran was saying, around keeping those things in mind around, I want to enable CI/CD, I want to enable DevOps and those methodologies within a regulated enterprise. So centralizing control leads to bottlenecks and handoffs and can fundamentally hamper that CI/CD flow. Your small numbers of standards, so if you're trying to achieve effectively the best cost point for the delivered functionality, this is going to hamper that. We're not going to be able to optimize the architectures and the designs of our applications to make them deliver the best functionality for the lowest price. And it also hampers innovation. And one of our key drivers in this was to deliver the capability for more innovation to the firm. And the one throat to choke, again, it kind of divorces the responsibility for the application teams from how they manage and maintain and think about their hosting environment. So with that, how do we think about how we federate that responsibility, but still maintain and manage the risks and controls for a large regulated enterprise? So effectively, what we've got to do is think about what's the new best practice for adopting public cloud in an enterprise like ours. And so with all that debt that you're paying down, with that change to your best practice, there's a lot of change that's coming into your organization. There's also a lot of stakeholders that are not inside IT. We deal with everyone from our legal departments, our tax departments, our risk and control functions. The list is pretty endless. It touches way far outside of IT. With that change, there's kind of a very natural reaction to change, which is it's human beings, and you've all got human beings in your firm, so you'll all have this. And it's kind of like that 5 stages of grief. You have the denial, the anger, the bargaining, the depression, the acceptance. And so we've seen things like, oh, we're a large regulated enterprise. This cloud thing isn't for us. We're special. It's all for those crazy startup kids into the denial phase. Our processes are fine. They've worked for years. Leave them alone. There's nothing to do. Anger, you guys are just trying to avoid all those controls. Or our standards say no. Bargaining, yeah, those guys need to change, but my bit's fine, right? We can just leave this bit alone. Depression, oh, where does this leave my role? It's all changing. And then into acceptance, and that's where the work really starts. So, okay, great. So how do we now establish our trust of AWS? That's the kind of questions that regulated enterprises have to ask. Okay, what do we do about managing variable cost? What does my role become? That's a good positive question. And then, the classic thing is, that's great. How do we get it done faster? So be prepared for this. This is part of the journey. You will need to spend a lot of time on this and bring those stakeholders with you and support them through this. But fundamentally, expect to see that kind of reaction.
Thank you, JT. I think if it's not obvious, and we're getting to the interesting bit now, I promise. When you think about being a technologist in an enterprise and you think about switching on public cloud, 60% of it's the technology. The whole rest of it is being a psychologist and being willing to kind of define the role very broadly across the organization, as we've found much to our chagrin over the last couple of years. So the next section is actually about what we're calling cloud anti-pans. We've got some of these things wrong, and we've iterated multiple times on these technologies and how we've implemented public cloud. What we're going to try and do is show you what we think is an anti-pan, try and explain why we think is an anti-pan, and then show you how we've implemented it at Barclays to mitigate the concerns of the anti-pan. As I said, you may not necessarily agree with all of the points. We're very open to having a further conversation with you, but if nothing else, it really will hopefully make you think about some alternative ways about delivering your technology. So with that, my pet peeve is cloud brokerage. To no offense to anyone who delivers and provides cloud brokerage technologies. Cloud brokers are essentially the idea that you use a third-party technology. Maybe you've built it yourself because you wanted to. Maybe you brought it off the shelf from a third party to control and act as the gateway into your public cloud platforms. There are many out there. We've looked at most of them. There are 5 issues that we think exist with cloud brokerage. The first is the optimization is limited by the capability of the broker. So the broker is effectively trying to keep pace with Amazon this week, with Microsoft next week, in terms of the set of features that are being delivered. And because of this, you're always going to have a certain lagging factor between what you actually want to use in terms of public cloud and what's available within the brokerage layer. So that innovation is really limited by what you can do. You can't necessarily go and switch on Sumerian from last night if you have to wait for third-party brokerage layer to catch up, or when you have to build it in yourself. There's also this question about optimization. Normally, when you think about brokerage, what you're talking about is defining a set of patterns of how people should use your platform. What does a virtual machine look like, or what does a container runtime look like in the public cloud? And while there are good things about that, and we'll talk more about that in the future, it also sets some very clear limitations. If you were trying to optimize the cost profile of your applications in your enterprise, which should be a very clear goal for all of you, you could argue that the number of application architectures, the number of configuration patterns, for want of a better term, should asymptotically reach the number of applications you've got in your organization. The more uniqueness you have across your estate, the more cost optimization that should be occurring. And so the natural inclination of an infrastructure organization to try and define a common set of patterns, define what a 3-tier web application should look like, may actually be a very limiting factor in terms of how you enable your developers to deliver cost-efficient technology to their business line. Number 3, abstraction is a myth. We started off with the idea that there was a Barclays VM. Barclays VM walked, talked, and quacked consistently across all cloud platforms. Well, that's true until you start to understand the semantics of each of the different cloud vendors. They use very similar words. They're quite different and have quite different implications. And the more you hide away the detail from the developers, from the users of the platform, who are, again, trying to optimize their workload for efficiency, for high availability, for disaster recovery, and all the other good stuff that you'd want, you're limiting their ability to really get closer to the metal to understand how their application will behave. So we think that abstraction is problematic. We also think that the core idea of arbitration, arbitrage. The idea that I'm going to pick up a workload from here and move it to there tonight or the next day is unlikely to ever really occur. For multiple reasons, mostly risk, but also the data gravity as well. So enabling your developers to choose their cloud platform, choose the workload, choose the technologies is beneficial, even though there is a degree of lock-in that comes with it. If you were Gartner, you'd talk about mode 1, mode 2. We'd talk about mode 6,000. Depending on the number of applications you've got, each application should have its own speed of delivery, its own speed of change in your organization. And then finally, if you're using a brokerage, you're also using a third-party proprietary API, maybe one you've written yourself. That removes your organization from using the 93 million web pages about AWS that we found a couple of weeks ago. All of those side projects, your hundreds, if not thousands of developers are working on in their spare time, none of that skill is transferable back into your organization. So our choice was to actually not put a brokerage layer in and provide our developers with direct access to the Amazon Console and API. And to explain how we did that, I hand over.
Yeah, so we still have the challenge without a broker of how do we provide access for our many developers into their AWS accounts and the roles within those accounts. So we developed internally a solution called the AWS Account Portal. Now, this isn't a brokering layer. This is actually a mechanism for federation. So this effectively links the user's Active Directory identity with IAM roles in the various accounts. So the key thing here is once they hit a landing page within the portal, it shows them all of the AWS accounts and the roles within those accounts that they are authorized to have access to. They can click onto that, and it will redirect them directly to the AWS account portal. So now they're not interacting via the Barclays portal. They are directly interfacing with Amazon, and that's a key point, that this is not a broker. It's merely a jumping off point. And so why did we do this? Well, one of the things is we didn't fancy managing the combination of AWS accounts times by the number of developers, times by the number of roles, and all of that complexity in terms of IAM users across all of that environment as people move, leave, join the firm, etc. So we wanted to achieve a federation solution for that. And so in order to do this, we used the AWS STS service, particularly the assume role action within that. We pass sort of useful context information from our federation solution to that using, within that call, the role session name variable. So, for example, we'll pass the username, or we may pass additional information such as change control record or information around the environment type within which they're operating, etc. And the reason that's useful is that gets all stamped now into the CloudTrail logs. And so at the back end of the system where we're doing all the auditing of what's going on where, that context is now flowing all the way through the system. And so obviously a key thing is that we're trying to enable automation, so our portal also is implemented with an API, so users can code against our API to assume temporary credentials using their internal Barclays Active Directory details. And this is really useful because it also helps us manage the risk. We see many issues with firms checking keys into GitHub, all that kind of thing. We're trying not to permanently hand out long-lasting keys. We want temporary keys to manage them this way.
One of the things we're trying to do with regards to this portal, we're working feverishly behind the scenes to be able to get to the point where we can open source that and make that available for other people to utilize. So that might be worthwhile. Whilst we talked about this idea of giving people direct access to the Amazon console, giving direct access to the APIs, and we'll talk more about how we put control around that, because that sounds a bit like the Wild West, and that's not the outcome. There are cases where you do want to have some commonality of approach. You do want to drive certain teachable moments and certain behaviors and certain common ways of working. And so we don't talk about patterns, we do talk about templates. The idea I can take something off the shelf, use that as a starting point, a quick start guide. And for us, we think infrastructure as code is fundamental to this journey, and we're using HashiCorp, Terraform, and Chef extensively, both for inter and intra-node configuration across our estate. What we found is that Barclays has been on a major agile journey for the last few years, but we've never really solved the last mile problem. So by creating common templates, using some common tools that know how to talk directly to Amazon, which is pretty key, which is, again, another reason for deploying this portal-type approach, means that we can, in a source, and build this kind of supermarket of common configuration, common behaviors for people to be able to compile and bring together some common application starting points, again, with the expectation they become more optimized over time. So we think that infrastructure as code is very important, but what we really think is key is being able to utilize the common APIs, be able to take directly from open source and bring it together.
Okay, so our next sort of anti-pattern after the brokers was around a small number of AWS accounts. And I think there's been quite a lot of conversation about this at previous reInvents. But as we started off, we sort of had this belief that we should try and keep the number of AWS accounts small, keeps it manageable. We don't want to have to maintain and manage many, many different accounts and all the credentials, all the configurations across all those accounts. However, we learned as we went along the journey that all that did was actually push problems to other parts of the solution, and in some cases made them more difficult than solving the many account problem. So, for example, we'd have the issues where with common and shared accounts, we'd have developers falling all over each other around different levels of access, who's got access to what bits and not other bits, and that became extremely hard to manage safely. The other key thing is around the cost of our applications. So in order to motivate that cost reduction for the firm by having an environment that means that you are motivated to reduce your costs, we need to make sure that that bill was very unambiguous and fully loaded. And we found that the only real way to do that was to give people their own AWS account with their own bill. We've seen many sort of approaches around using tagging for this. However, we had challenges around how do you know that the tagging that you're using is of high integrity? How do you know people are using the right values, the values they're allowed to use, not effectively putting it on someone else's bill by using their tag? And there are certain things that you can't tag and get the cost allocated, so your network bandwidth usage. How do you make sure that that's apportioned to the right people to pay the right price? We also, as we said before, we saw this as a bit of a key point of opportunity, and we think that with the sort of small number of accounts sharing all in those accounts would have been a lost opportunity for security. And lastly, as we'd scale up, we'd start to hit the soft and hard limits within Amazon. So those limits do start to become things that you really have to think about and manage and design around, and awareness of those is really critical as usage scales up. And with a small number of accounts, we think we would probably hit those limits much earlier and with fewer options to address how we'd move past those.
So it should be fairly obvious that given we built a portal and we're talking about a small number of Amazon accounts being an anti-pattern, we've taken the approach that we've seen referenced in a number of other enterprises and taken it to, you might say, the nth degree. So we're all about microsegmentation. We microsegment at the Amazon account layer itself. And we'll go into a lot more detail about how we do that in the next couple of slides. What I wanted to do is draw your attention to the right-hand side of this slide. There's an inverse relationship, we believe, between the set of controls that you want to apply around your cloud environment and the risk appetite of your organization. Your risk appetite and controls tend to be very strongly correlated today because you don't have, I would suspect, a very strong segmentation strategy within your core network. And so as a result, dev, prod, they're all very close to one another, and therefore you have to orientate towards the highest order function that operates in that environment. We tend to put production controls around development environments. But that doesn't feel like the right way to think about this. So if you invert their relationship and you tend to increase the number of controls as you head towards production, and you decrease your risk appetite as you tend towards production, you end up with this ability to be able to layer the right controls in the right places for the right things and at the right time. And so the segmentation of the Amazon account allows us to apply very different policy on a per application, per jurisdiction basis. So what does that mean in practice? Well, on the left-hand side, we talk about a few of the cases where this really helps us. So Role-based access control, we talked about the portal, that's one part of the journey, who has access to which accounts, in which context, and at which times. But also, if you're using different accounts, now you can start thinking about a wholly different set of services per account. Some of your organization will have a much greater maturity level than others. Maybe they can be trusted to use certain capabilities that you wouldn't normally provide. Maybe you want to think about a set of services from Amazon as some being generally available. They have industry de facto APIs associated to them, and some things which are more special order, things that are increase the lock-in, but also at the same time increase business value. And so we don't think that lock-in to a given technology is a bad thing, as long as you can extract the right business value that comes out the other side. So thinking about how you can use IAM policy to actually enrich and use different capabilities in each account seems like an interesting thing. The fully loaded bill, so as JT mentioned, we want to track the cost of every single byte going across the direct connects for each application. Some of our applications have never really considered the cost of bandwidth when they're architecting their applications. The core network, very large, very fat pipes, free by all accounts. Except it's not free, we know that. But the developers don't necessarily see the cost of those things. And when they don't see the cost, they don't know how to optimize. They don't even know if it's an issue. So you really want to get to the point where you can fully load the cost. And we'll talk more about how we actually cost out the infrastructure portions on the next slide. But the idea being, you generally want every single cent of spend to go back to the application manager. What we talk about at Barclays is a cost to value ratio. The value accrued to the business should be commensurate to the cost to the business. And normally, if you can't see both of those two things, you don't have line of sight, you can never know if it's the right price point for the technology, it's the right price point for the business. Our goal here is to get to the point where our developers, our application managers can have a meaningful conversation with their business about, is this the right amount of spend for this type of application, whether it's HPC, a retail mobile banking system, or whatever it may be. Tax is just an example of some of the jurisdictional matters you need to think about. Which tax bracket, or which tax jurisdiction, I should say, is the cost of the Amazon account, and is it the right place for the business? You might want different accounts in different regions to represent some of the business operations, some of the structural behaviors of your organization as well. And it should be obvious, security isolation. We talk a lot about north-south controls over the last 10, 20 years. The last few years we talk about east-west. Well, how about thinking about all of it? What's the 360-degree security posture around your applications? If you safely ensconce every application in effectively its own mini DMZ, it becomes an interesting model in terms of how applications have interconnectedness. One stage further, if you want to get really crazy with this, the idea that your Amazon account is commensurate, has a direct correlation to a box in a box and wire diagram that represents the enterprise architecture of your bank. Those two things become very synonymous with one another. The lines that you draw between applications in a very abstract form actually start to represent flows in security groups and connections between your Amazon accounts as well. And finally, microsegmentation allows us to horizontally scale our direct connects and VPNs across hundreds to thousands of Amazon accounts. So what does that mean in practice? Well, in practice, this is what an Amazon region looks like today. We do not allow accounts to be multi-region. They are specific. So you can see how the scaling starts to become orders of magnitude harder over time. But we do have a very well-defined topology. The same cookie-cutter regional deployment is made time and time again. And in effect, what we're actually doing here is not just creating accounts per application, as I said, HPC, mobile banking, whatever it will be. We're actually deploying each of the infrastructure components into their own Amazon accounts as well. So we're taking the idea of microservices of an application and thinking about how infrastructure is also a set of microservices. Now that has a really interesting byproduct. It means that we've got people in an organization responsible for those Amazon accounts. And they're responsible for their bill because they've got to work out how to recharge that back to the users of the platform. So it drives cost efficiency in the way you deliver infrastructure as well. And, as should be obvious, there's very clear separation of duty. Now, the question then, of course, is, well, how do you manage that at scale? And how do you build that many hundreds, if not thousands, of accounts? And JT's going to talk to you about that.
Thanks. So in order to spit out many thousands of AWS accounts, which is where we're targeting at. We needed basically a factory for those. And so an awful lot of the work we've been doing has been around making the factory. So I think it's worthwhile just mentioning, we kind of extend the shared responsibility model you hear from AWS internally within Barclays. There's our, where Kieran and I are within the infrastructure function, we lay down a base level configuration into the AWS accounts. And that gives the application teams we hand the account over to the environment within which they can now deploy their parts. So in order to become an organization that has the capability to deliver that factory, we within infrastructure had to create ourselves as a development function. So we had to go through some of that change that I mentioned earlier as well. We had to take on the challenges of around automated testing, CI/CD for our own tool sets and our own software that is this factory. And we had to learn an awful lot for how to create the relevant test environments to test whether the factory is creating AWS accounts that look and smell exactly as we want them to. And so what do I mean by the base configuration? So what I mean by that, they're the parts that we own in infrastructure. They are part of the shared responsibility model. It's also, we put into the accounts various controls that are designed in such a way to be as inobtrusive as possible. So really they are kind of acting behind the scenes. So we want to get out of the way so that the application teams can be productive. And then also we need to wire in that AWS account into the wider Barclays environment. So that may be anything from the connection to the direct connect, the routing. It may also be things such as our CloudTrail log, sending that off to our log archiving services and systems as well. And so some of the lessons learned that we went through as delivering this factory is at first we thought this was like the infrastructure as code we were talking about earlier. It was a problem that one of those tools would help us with. And actually we found that those tools are not great with these sort of split responsibilities. So where we think they're really good for where the application teams will take over and do their bit, they're not so good for where we had some part of the responsibility and the application teams had another. So for us doing some of the foundational level, what would it mean to use an infrastructure as code tool to set up a subnet when later on someone comes and puts an EC2 instance on it and then I need to upgrade the subnet with my infrastructure as code tools? Some of them take a fairly destructive approach to that, which may in certain situations not be appropriate. So we actually developed our own tooling to deliver this factory and effectively developed our own SDK based on top of Boto 3 as well for how we manage the delivery and the life cycle of our AWS accounts. Another lesson learned is that your root user credentials in AWS accounts are a real pain. And you will end up with a lot of them, and you need to come up with a good way for securing those. And we in Barclays actually split the responsibility of the two factors of authentication for the root account across two separate parts of our organization. But we're hoping that services such as AWS organizations are going to start helping us in the future with some challenges like that. And then, I forgot my last point. The other thing was interconnections between AWS accounts are also something which are difficult to manage at scale. So sometimes you may want to design around those. So for example, we send a lot of events and logging information out of our accounts. And for each of the things that's going to send an event, we started off creating another configuration for this thing to send it to a central account for that logging or central account for monitoring that event. And we ended up with a lot of interconnections between accounts, which became incredibly hard to manage over time. So we actually developed sort of a more enterprise bus mentality around those interconnections. And I see that with some of the relatively recent announcements from things like the CloudWatch Event bus, you're starting to see Amazon sort of deliver some things which help in that area as well. So the next thing we'll talk about, although it's very infrastructure as service focused, it's probably quite a good example, but we're not just interested in infrastructure service, we are looking at the whole suite of AWS services. And this is probably quite a good example of something we had to think about when looking at the approach as a foundational platform rather than for a specific use case. You wouldn't have actually seen this come to light under a specific use case. So we had a requirement that only Barclays curated AMIs should be used in our accounts. And in order to achieve this, what we do is we actually import the AMIs into every single one of our accounts. And the reason we do that is we can make use of a clever IAM condition that means that you can only run up instances that are owned by the local account, which avoids me having to manage a distributed whitelist of different AMIDs across many thousands of accounts, which becomes really hard to maintain over time. But what it does give me is a challenge with managing the life cycle of those AMIs. So I've got to somehow release the new AMI to all of the accounts. I've got to be able to mark it as deprecated to communicate to our developers that it's about to disappear. And then fundamentally, at some point, I've got to remove it once its lifetime is over. And so in order to do that at scale, we came up with a solution where we have a central S3 bucket that provides effectively a golden source for the images. And as we manipulate the images in that bucket, whether that's to upload a new image or delete an image, or to change the tags on that image, that effectively sends events out, which are picked up via SNS by Lambda functions in all the various accounts. And then they react to pull that image from the bucket and import it locally. They also look at the tag values, which we use to signal whether the lifecycle status has changed to deprecated or whether it's now to be retired and removed. And this is an interesting thing that we had to think about at scale. There are means to share AMIs across accounts. I'm sure many of you are aware of that. But they have scaling limits around how many accounts can I share that with. So for example, we encrypt our AMIs with KMS. So how big can your KMS resource policy get to allow access across all of those accounts? How many accounts can you actually share an AMI with? Some of these things that we started to hit scaling challenges of, and we came up with this solution to help us here.
So the next anti-pattern is centralizing administration. And you probably caught up on some of our themes here. What we're really trying to do is to create a safe environment, effectively sandpits for every single development team in Barclays to be able to move at their own pace. We are federating accountability to the leaf nodes of our organization. And so it should be fairly obvious that we're not necessarily appreciative of this notion of centralizing administration. There are some challenges around CI/CD. It reduces productivity. It creates an ability for someone to kind of shirk responsibility and saying, someone's going to catch me for making mistakes. I don't need to be held personally accountable. We think they're bad sets of behaviors. But we also think there's another issue in here which I wanted to highlight. It is common to think about patterns and control when you apply it into an enterprise to be applied at the point of inception of the thing. I'm going to build a new server. Well, that server needs to be imbued with a set of capabilities and a set of controls from day zero, knowing that that should protect that environment, should make that server fit for purpose inside Barclays or your own enterprise. But the problem is, most of those controls are only applied at the point at which the machine is brought into existence, or the container, or the serverless architecture, whatever it may be. And invariably, as I'm sure many of you experience, a degree of entropy will enter into your organization over time. There will be a deviation between the expected norm of that server and the reality in some number of months or years' time. And so most people tend to think about centralizing administration also being a centralization at a point in time. And we're going to try and convince you that that may not be the right thing to do, so if you may. Again, not necessarily an original thought from us, but we do want to spend a bit of time talking about this notion of continuous compliance. How do you use the technologies that Amazon provides and other cloud vendors to think about applying control incessantly, always and forever? You have now an API into your data center, something most of us never really had, the ability to continuously integrate, understand what's happening in your environment. Why not react to those state changes? By reacting to state changes and immediately removing the deviations allows you to course correct every single component in your data center, virtual or otherwise, from now until the future, until the piece of technology is removed from your organization. So tracking all the activity, monitoring it, looking for state change, and then automatically converge anomalies becomes a really powerful mechanism. We end up with both preventative, the IAM policies that we deploy through the Amazon Account Factory, and reactive, detective controls, always and forever through reactive Lambda functions.
Yeah, so as Kieran mentions, we make use of preventative, reactive, and detective controls. So preventative, fundamentally, you'll spend a lot of time with IAM. You will become an IAM ninja. I think there is an IAM ninja breakout session, so maybe that's worth having a look at. But your IAM policies will become very important code to you. So we manage that in source control. We implement automated testing. It's released through continuous integration. It's effectively part of the factory that I mentioned earlier in terms of how those roles are managed and released. And you will come up with some very inventive and clever ways of combining various different IAM conditions and various double negatives, triple negatives on not action with not resource, and it all gets quite complicated over time. So that's why your testing is important, to make sure you don't bring in any regressions into that. But also, the reactive part has become a huge part of what we do. We're a huge fan of the very simple pattern of using CloudWatch Events with Lambda functions. There's some examples here of some of the things that we use this for. So when we started this journey, there wasn't the ability with IAM to prevent people creating EBS volumes without using KMS. There is now, but nonetheless, we leave it in as a supporting capability for us to actually, if we detect the creation of an EBS volume without encryption, we delete that volume. May sound a bit harsh, but fundamentally, we believe this becomes an educational moment for the people using the account, is that they'll soon figure out that this is not a successful path they're going down, and ultimately that educational path is much better than having something written in a document somewhere that someone wrote and no one's ever read. We also had to look at things such as snapshot ingress. So as well as data leakage and loss from an enterprise like ours is very important, so's the ingress. We don't want certain software that may be malicious entering our firm. In Amazon, I could share a snapshot and it would be available to any of you in any of your AWS accounts to copy that into your environment. For us, with our shared responsibility, what we wanted to do is prevent the users that we give access to the accounts, and with giving them the permission to use snapshots for their own valid purposes, we wanted to prevent them using it for bringing data into the firm where we shouldn't. So we react to copy snapshot events, and if we see that the source of that snapshot was not within the same account, we delete the copy. So again, it's not a successful way of bringing those things into the firm. With things such as security groups on ELBs, when we create the ELB, we're already entering a lot of information around what the ingress and egress points for that ELB are. And so just to support best practice, we detect that and automatically put on an appropriate security group on that ELB. Bucket policies, we're probably all very familiar with some of the publicly shaming points of people not configuring their bucket policies properly. When we create a bucket, we react to that event and we stamp on an appropriate bucket policy so that we don't accidentally expose things out to the internet. And then the last point is actually really more a point around how we maintain our environment. So with EC2, there's a lot more that we have to do, and part of that is around some of those integration points into the wider Barclays system. So we put our EC2 instances into our own DNS systems so that it's resolvable from on-premise as well as within the cloud. We integrate them with Active Directory. We use Chef and Chef servers, etc. So what do we do when an instance gets terminated? We don't want to get in the way in some sort of brokering way to intercept that event. What we want to do is detect that event afterwards, react, and then clean up those systems sort of asynchronously behind the scenes. And so, I think the key point here is that educational moment. We really are looking to how to drive greater knowledge in our application development teams around what are our standards in the firm in terms of the right way to operate, what's safe, and we think that's really important. And then, of course, there's detective controls. So CloudTrail may not be the most exciting service, but for enterprises, this gives us your view of every action that's performed in your virtual data center, something we've never had before. And we've integrated that closely with our existing sort of privileged access monitoring processes and controls. And we're also working closely with Chef on their Inspect product, where we are using that to continuously monitor the integrity of our own controls, the base level things that we put into the account. So as well as having that continuous course correction, as Kieran was talking about, we're also making sure that the things performing the continuous course correction are also still of the right integrity. So all of that around the detective side as well. So then this is an interesting example of how the mindset starts to change, and a bit of an example around the shared responsibility. So because we've taken the foundational platform approach, and it's not a specific use case, we do not know up front the security group requirements of that application. Neither does the developer when they start developing, right? You start and you probably don't know all the interconnections that you're going to need until you've kind of got to your first release. We also have certain infrastructure-based communications that we need to make sure happen that the application teams shouldn't really have to care and worry about. So when an EC2 instance is brought up in our account, we detect that and we automatically apply the infrastructure-based security groups. So from an infrastructure point of view, that EC2 instance is integrated into the environment. And that's done without the developer having to think or know about what rules am I supposed to put in my security group, which security group should I be using, et cetera, et cetera. That's done for them. We then give them the ability to create their own security group to apply to that as well. So they can capture their information that they will know. We won't know that in infrastructure. We don't want that to come back to a central group to, can you please set up my security groups? Because that, again, is part of what we mean by that straight-through processing. We want the application development teams to do that themselves. And the really interesting bit here is that we decided that once we've actually got that information captured in the security groups in the account, we have a firewall at the south end of our direct connect. We need to get appropriate rules into there as well. And we actually decided that we would use the information captured in the security groups to feed into automation we delivered for that firewall as well. So effectively what we're now doing is using the AWS API and Web Console as an ingress point to our own on-premise automation as well. So it's an interesting way that we haven't had to go and develop our own APIs and develop our own web UIs for our internal developers for some of the automation we now do on-premise. So whether you call that hybrid, I don't know, but I think it's quite an interesting pattern for how we've been able to use some of the AWS services for actually automating some of our on-premise things as well. So it's just an interesting example for that.
And with that, we've made it to the end, so we're into conclusions. So I guess I was going to talk about this in particular. We've mentioned a few of these things, right? And I really want to kind of reiterate them again. Delivering public cloud inside your enterprise is not an infrastructure-led program. It is a software development practice, first and foremost. And being able to get an interplay between your engineers and software developers to learn from one another, work together, build software, test it, deliver it in an agile fashion as a set of microservices becomes a really powerful paradigm that actually shows us in infrastructure how our developers, how our users actually operate. So we think very strongly about this idea of development, acting as a development team. We're also very much focused on federating this accountability down through the organization. And to do that, IAM is a critical component. And treating its source code in the same way as you would maybe a Python or Java code is absolutely essential to be able to do this kind of, solve for this kind of problem at scale. And as we said, there are many different patterns and templates and optimization plays within your environment, and it would be a shame to optimize too soon and too early for your application developers to be able to utilize the full power of the kinds of capabilities that are provided to you. And that's really it from us. What we will do, though, is we're going to put one more slide up, because I know some of you like taking photos. We could talk for another 2 or 3 hours about this. They're probably going to kick us off the stage. But these are some other things you might want to be thinking about. So if you want to take the opportunity to take some photos, please do. And with that, I'm going to hand back to James. Thank you.
Right. So, yeah, thank you very much, Kieran and Jonathan. Actually, a personal thank you, because you've been, like you said earlier, you've seized the moment to really tackle some very important challenges and really change the state of the industry, so thank you for that. And actually thank you to the broader Barclays, all the other teams and functions that I know are heavily committed and support you in making this big change, so thank you very much indeed. And so thank you to everyone for your attendance and your attention. Hopefully that's very useful. Please fill out all the session feedback forms so that we can continue to drive the best content for you. So thank you very much indeed.